This week, we're going to talk about univariate descriptive statistics. Next week, we're going to be talking about multivariate descriptive statistics. This topic of descriptive statistics is probably one of the most important topics in statistics because you're going to be using it more than just about anything else. I know that you've probably been studying descriptive statistics since junior high school or maybe even earlier than that, but it's used so often and people really don't understand the subtleties of this topic. So that's why I spend 2 weeks on it here in this class. So first off, what is a univariate descriptive statistic and why do we care about it? Well, descriptive statistics summarize some data. On this slide on page 26, I call it a batch of data following John Tukey, a famous statistician, and he uses the term batch to avoid the distinction between samples and censuses. So why do we want to summarize some data? Well, to motivate this, let's go over to the defaulting customer data that you've read in. Now, if you haven't read this in, go watch the video that I created on how to read this in, and make sure that you can read it into SPSS. Then come back to this video. One of the variables from this defaulting customer data set is down payment. So that's the third column in. And recall that there's about 25,000 cases in this data set. If we wanted to understand down payments, well, we could page down through this and look at down payments, and you'll see, well, there's a lot of hundreds and there's a fair number of 150s. But to be frank, this data set's kind of overwhelming with 25,000 cases, and we're going to be paging down for a long time to make sense of this. So what we'd like to be able to do is to somehow summarize all these 25,000 values of down payment so that we don't have to page down forever. I compare this to walking around on the ground versus flying in an airplane. So picture yourself walking through the forest. That's equivalent to us paging down through this data. So if we're walking through a forest, we're going to see a whole lot of things. At some point we might run into a stream, then we're going to run into a hill at some point, and maybe we see some trees. All right, so that would be like me running into this 100 and then the 70 and so forth. But when you're down on the ground, it's hard to get much perspective about this area. You really need something else like a map or an aerial view to make sense of it all. So now consider going above this forest that we've been walking around in. Now from an airplane or a hot air balloon, all of a sudden we could see how that stream relates to the hill and how that relates to a clump of trees. So you can sort of understand how all the shape of this forest. All right, well, that's exactly what descriptive statistics do. So on this page 26, I list some of the things that descriptive statistics will tell us. So for example, one question that we often have is what's a typical down payment? Well, typical down payment means where is the center of the distribution? We have numerous measures of the center, like the mean, the median, and the mode. And so that tells us what's a typical down payment. Another question that we might have is how concentrated are these down payments? So that's a question of spread. Are the down payments all spread out, or are they very homogeneous? So if all people have roughly the same down payment, the spread is going to be very small. Conversely, if some people put down very little and some people put down a whole lot, that would indicate a very spread out distribution. All right, so all of these things we will be covering during this week's videos. Now on the next page, you're going to see how to run these in SPSS as well as other software packages that you might encounter at various places. Now I break this up into categorical and numerical variables. That'll follow this lecture. Let's go over to categorical variables. Now I know you've been doing categorical descriptive statistics probably since grade school, so we're not going to spend a lot of time on this. You get all of one slide. It is a very important topic, and it's probably simplest to understand these things with nominal level variables, so we'll spend a minute on it. Let's go back to the California Pizza Kitchen survey. One of the questions on there was, what one area would you like to see improved? Respondents could answer things such as decor, taste, service, new items, and so forth. So how can we summarize this? Well, the most basic way to summarize a nominal level variable or categorical variable is with a frequency distribution. I like to say that everything starts with a frequency distribution. So frequency distribution simply shows all possible values that that variable can take. So you'll see the 6 possible values here. Frequency distributions give us counts of the number of respondents who gave each of those responses. So for example, if we go over to the count column for decor, you'll see that there are 2,297 people who indicated that decor was the area that should be improved. At the bottom of a frequency distribution, you'll usually see a total row. So if we add up all these counts, you're going to see that there are 11,738 total responses to this question. The next thing that you should know about frequency distributions is that there is usually a column for percents. For example, this 19.5689% indicates that, call it 19.6% of all respondents checked that decor should be improved. You should also know where this number comes from. So where do we get 19%? I'm going to bring up a pocket calculator for a moment, and let's just check that we know what's going on. So this is a really important skill. You always want to make sure you understand what the output is telling you. So that 19% comes from the 2,297 people who said that decor was most important, divided by the 11,738 people who answered the question. So you'll see in my pocket calculator that gives us 0.195689, which is exactly what the output shows. So that's about it for frequency distributions. You should be able to understand the counts and the percents and how they relate to each other, as well as the total row. The next thing that we often want to do with a frequency distribution is to show it with some graphical display. The two most commonly used graphical displays are probably the bar chart and the pie chart. And again, you've been seeing these things since grade school, so we're not going to spend a lot of time on them. But I do want to indicate a few things about them that your 5th grade teacher probably didn't tell you. Let's start with the bar chart. So the purpose of a graphical display is to help us visualize the data and make sense of it in a way that the numbers in a table really can't do. So we're going to encode the numbers in the table using graphical devices. So bar charts use 3 different graphical devices to show us these values, the counts or percents. One way is that the areas and the lengths of these bars, so those are 2 different ways, the lengths of the bars as well as the areas in the bars are all proportional to these counts as well as the percents. So for example, we see the value bar is much longer than the service bar, indicating more people checked value than service. And if we go over to our table, sure enough, 28% checked off value, only 4% checked off service. The third way is that the end of the bar along this common scale indicates either the count or the percent. Now in this case, we're showing percents. So if we look at, for example, the end of the bar for decor, that end of the bar is a little bit less than 20%. So the end of the bar is encoding this 19 point whatever percent. Actually two more things you should know about bar charts. Bar charts always put a little bit of space between the bars. That space between the bars is a visual cue that these are categories as opposed to a continuum. We're going to look at histograms next for continuous variables, and that space between the bars has been removed. The other question that I often get about bar charts is, should you have them as a vertical bar chart or horizontal bar chart? In this case, you're seeing a horizontal bar chart. The answer is it doesn't really matter. I've chosen to use a horizontal bar chart because you get a little bit more space for your labels, whereas if this were a vertical bar chart, we'd have to, it's a little bit harder to show these labels, but it doesn't matter whether it's vertical or horizontal bar chart. The other graphical display for showing a frequency distribution that's used quite often is called a pie chart. You've unfortunately seen too many of these. Pie charts also use three different devices for encoding the data in this frequency distribution. So the three ways are areas, angles, and arc lengths, all of which are proportional to the counts and the percents. So if we look at the value slice is a whole lot bigger than the service slice. The angle for value is a whole lot bigger than the angle for service, and the arc length for value is much longer than service, indicating that more people checked off value. Another graphical display that's become quite popular is called a word cloud. On Blackboard, I give a link to a recent Washington Post article that gives some kind of fun word clouds to look at. Let's go over to Wikipedia for a second. So if we go over to Wikipedia, they show you various word clouds. Here is one for the population of the world. Now, the way a word cloud works is that they use the font size to represent the counts and percents in a frequency distribution. So picture a frequency distribution of the population of the world. We have various countries, and so if you look at this word cloud, China has the largest font, followed by India, because those are the two most populous countries. United States, it looks like, is third, along with Indonesia. Bangladesh is quite large, as is Brazil and Japan and Pakistan, Nigeria. All right, so again, just as we encoded the lengths of the bars and the areas of the bars representing the counts, here we're using font size. That's about all I want to say for frequency distributions for categorical variables. Let's now move on to numerical variables.